Okay, for today's lesson, we are going to build off of yesterday's lesson, and we're going to work with greatest common factors again, only this time it's going to help us reduce fractions easily, even when we're given really big numbers. Okay, so let's start by putting the heading on our paper, and this is going to be called simplifying, which is a fancy name for reducing, simplifying fractions using division ladder. And as always, make sure you date your notes. All right, let's review what a division ladder is. So please take a look at your notes from yesterday. Okay, and I'm just going to start off giving you some examples, okay? And then we'll talk about whether or not you notice any patterns. So, some examples. Let's start with, let's go with 8/20. So here's my fraction, and I'm asking you to reduce this. Put this in lowest terms. And some of you might know this right away, and some of you might not. All right, but all of us are going to show our work using the division ladder so that when we get to big numbers that we don't know right away, you know how to start them, where to begin. All right, so same as yesterday, I'm going to go off to the side and I'm going to write my two numbers and draw my upside down division sign. All right, and once again, we're going to start with the lowest prime, which is 2. Can 2 go into both of these numbers? Using our divisibility rules, we know that the answer is yes, because they are both even numbers. All right, what times 2 equals 8? The answer is 4. What times 2 equals 20? The answer is 10. Okay, start again. Can 2 go into both of these numbers? Yes, because they are both even numbers. What times 2 equals 4? 2. What times 2 equals 10? 5. Start again. Can 2 go into both of these numbers? No, because they are not both even numbers. Can 3 go into both of these numbers? Well, the answer is no, because you're not going to multiply 3 by anything that's going to give you 2. So we are done. Now, we know that the greatest common factor is 4. So I'm going to divide both of these by 4. And my answer will be 2/5. Take a look at that for a second, and then we're going to do another example and see if we notice anything about our work and our answer. Okay, next example. Excuse me. Our next example is 12/24. I'm going to go off to the side, just like we always do when we use the division ladder. Draw our upside down division signs, and start with our divisibility rule. Can 2 go into both of these numbers? Yes, because they are both even numbers. What times 2 equals 12? 6. What times 2 equals 24? Those of you that have been practicing your facts know that that is 12. Okay, start again. Can 2 go into both 6 and 12? Yes, because they are both even numbers. What times 2 equals 6? 3. What times 2 equals 12? 6. Start again. Can 2 go into both of these numbers? Nope, because they're not both even numbers. How about 3? Can 3 go into both of these numbers? Yes, because 3 can be divided by 3, and 6 can be divided by 3. So I'll draw my 3 off to the side. What times 3 equals 3? 1. What times 3 equals 6? 2. And I know that when I see a 1, that means I am done. All right, so let's find our greatest common factor. 2 times 2 is 4, times 3 is 12. So my greatest common factor is 12. I'll divide both of those numbers by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. Now, what do you notice about our answers and our division ladders? Well, we can actually eliminate this whole step right here if we do our division ladder correctly, because the numbers that we're left with on the bottom are going to give you your fraction in lowest terms. So we know right away the answer is 1/2. So this is our answer. And if we look at our previous problem, our previous example, 2/5 is what we were left with, so that is our answer. All right, let's do another example. The next example is 24/36. I want you to go ahead and pause this recording, pause this video, and I want you to try this problem on your own. And start the video back up again when you're ready to check your answer. All right, let's see if you're correct. Let's start with our divisibility rules. Our lowest prime is 2. Let's start there. Can 2 go into both of these numbers? Yes, because they are both even. What times 2 equals 24? 12. And we had this problem yesterday. What times 2 equals 36? Those of you that remember will know that that is 18. All right, let's keep going. Can 2 go into both of these numbers? Yes, because they are both even. 6 times 2 equals 12. 9 times 2 equals 18. Draw our line again. Can 2 go into both of these numbers? No, because they are not both even. Can 3 go into both of these numbers? Yes, because my divisibility rules let me know that. 6 divided by 3 is 2. 9 divided by 3 is 3. And like we said yesterday, if you get an answer that is one number apart from each other, you are done. 1 is our magic number. All right, and we don't even need to find this greatest common factor anymore because we know that we did our division ladder correct, and this means our answer is 2/3. So 24/36 equals 2/3. I want to give one more example problem and have you check it, and this is going to be a really tough one. All right, I hope you're ready. Let's try 126 over 342. All right, let's pause the video. I want you to try this one on your own and turn this back on when you're ready to check your answer. Okay, let's see if you're correct. So you went off to the side and you wrote these numbers out. And as usual, we're going to start with 2. Can 2 go into both of these numbers? Yes, because they are both even. Now you're saying, what in the world is 126 divided by 2? And some of you may have went off to the side and had to work this out when you shut this video off. So 2 goes into 12 6 times. Subtract, carry down that 6. 2 goes into 6 3 times. 3 times 2 is 6. Subtract, we have no remainder, so 63 goes there. And let's do the same thing for the other one. 342 divided by 2. 2 goes into 3 one time. Subtract 1, bring down the 4. 2 goes into 14 7 times. 7 times 2 is 14. Subtract. Bring down that last number. 2 goes into 2 one time. 171. Wow, still a really big number there. But we can do this because we know our divisibility rules. Okay, can 2 go into both of these numbers? I hope none of you put that because neither one of these are even numbers. They both end in odd numbers, which cannot be divided nicely by 2. Okay, so let's move on to 3. Can 3 go into both of these numbers? Well, my divisibility rules say I need to add 6 plus 3 equals 9, and 9 can be divided by 3, so that one will work. 1 plus 7 plus 1 also equals 9, and 9 can go, and 3 can go into 9, so I know that one will work for 3. So let's go ahead and put our 3 here. All right, this one's going to take some work. All right, off to the side. 63 divided by 3. 3 goes into 6 2 times. 0, bring down the 3. 3 goes into 3 1 time. Our answer is 21. All right, 171, same thing. Divided by 3. 3 goes into 17. How many times? That's right, it goes in there 5 times. Bring down your 1. 3 goes into 21 7 times. 57. Wow, still a big number. Okay, we can do this. Okay, we know 2 does not go into these numbers because they are not both even numbers. Okay, so let's try 3. 2 plus 1 equals 3, so yep, 21 can be divided by 3. 5 plus 7 equals 12, and 12 can also be divided by 3. So 3 will work again. And I already know my facts, so I know 7 times 3 equals 21. Now 57 might be a little bit more difficult, but we can do this. All right, let's go off to the side one more time. 57 divided by 3. 3 goes into 5 1 time. Subtract, bring down your 2. 3 goes into 27. 9 times. 9 times 3 is 27. Subtract, and the answer is 19. Now, I know the difference between prime and composite, and I know that the only way I can get 7 is to multiply 7 times 1. And I know that the only way I can get 19 is to multiply 19 times 1. So since I have 2 prime numbers, and neither one of them have a shared factor, a greatest common factor, I am done. All right, I don't need to find the greatest common factor from the side. And my answer is right here. My answer is 7/19. That was a lot of work for this problem. But I wanted to prove to you that no matter what fraction you are given, you always have a place to start. Okay? Once you've attempted this problem, you can let your teacher know that you are ready for the assignment.